Titrations. Titrations is the last topic that we are going to cover in this unit. Before we get into what titrations are and how they're useful, I'm going to ask you this question. Let's say you move into an apartment and you find this random bottle under the sink, okay? So let's say you find an acid on a shelf or under the sink, and you have no idea what the concentration of that acid is. How do you determine the concentration? Okay, is it concentrated? Is it gonna kill me? Is it so weak that it's not gonna do me any harm? What is the concentration of it? So before you could determine what the concentration is, you have to understand what a neutralization reaction is. So a neutralization reaction, just by looking at the name, it means you're gonna produce something that's neutral, and it's going to form a reaction. So for example, a strong acid is going to react with a strong base to produce salt and water. This is called a neutralization reaction. But what is the purpose? What is the purpose of mixing a strong acid with a strong base? Well, the purpose of it is to achieve a pH close to 7. You can't dump a strong acid down the sink. You can't dump a strong base down the sink. You have to neutralize it, and then you could dump it down the sink so that it's safe. Okay, so the way you neutralize is you add a strong acid with a strong base, or a weak acid and a weak base, and that will generate a neutralization reaction. So when you add an acid and a base, it tends to form a salt, not always, but it tends to form a salt, such as sodium chloride. When you mix hydrochloric acid and sodium hydroxide, you're going to form salt and water. Okay, now let me remind you about how podcasts form. When you listen to a podcast or a video, if you don't understand something, you pause it and you start over. Okay, you pause, right, pause, highlight, go back, okay? So that's how podcasts work. Now, we know what neutralization reactions are, and we want to know, how am I going to find the concentration of that acid that I found? Well, you have to consider 4 things. For every OH anion, for every base, such as this one, OH, you can neutralize it by adding 1 H+. So for every OH, it will accept 1 H+. Okay? If you have a strong acid, so let's say you have a very, very strong acid, you can neutralize it by adding a strong base. Okay? You can't neutralize a strong acid with a weak base. It's going to take forever for you to neutralize that strong acid. So it's better to use a strong base and not a weak one. So when you mix a strong acid and a weak base, it's going to reach a pH close to 7. At a pH of 7, that's when the amount of base added to neutralize the acid will equal each other. So you have an acid, I'm going to add base until it reaches a pH of 7. Whatever amount of base you added to that bottle that you found, that's going to equal the amount of base needed to neutralize the acid. It's going to be an equal amount of both. Okay, there has to be an equal amount of H plus and an equal amount of OH in order for something to be at a pH of 7. This concept is depicted, is shown through this formula. So MB stands for the molarity of the base. The molarity of the base multiplied by the volume of the base is going to equal the molarity of the acid times the volume of the acid. So both of these are the same, except one side corresponds to the base and one side corresponds to the acid. You could also flip this. This could be MA, VA is equal to MB, VB. So they're the same. This is in moles per liter. This is in liters. This is in moles per liter. This is in liters. So volume is only liters. Molarity is in moles per liter. Now, if you're in my honors course, you're going to be doing this, okay? If you're not in my honors course, you're not going to be doing this. But you will do something similar. Now, I have a question. How do you know when the pH reaches 7? That's when we start using indicators. So we learned about indicators a few days ago. An indicator is something that changes color in the presence of a different pH. and a difference of whether something is an acid or a base. That's when it starts changing color. So using a neutralization reaction, you're going to find the concentration using something called a titration. A titration is a technique, okay? This is very important because your last lab report for this semester is going to be on this lab right here. For if you're in my honors course, it's going to be on this lab. Now, indicator changes color, titration, okay, what the heck is this? Let's get to it. So how are indicators used in titrations? Well, this is the experimental setup. This is called a flask. In this flask, you have an acid. It's of unknown concentration. Let's pretend this is not pink, it's actually clear, okay? So we do not know the concentration of this acid, but we do know the volume because you can measure it using the flask. Okay, the flask tells you, like, there's little lines and it tells you the volume. This base right here, this is going to be the base, and you know the volume because it's shown by the little lines, and you know the concentration because you could just look at the bottle. Look at the bottle, it'll tell you the concentration, and look here and it'll tell you the volume. We don't know the concentration here, but we do know the volume. So if you look at this equation again, we do know this. We know the concentration of base. We know the volume of the base. We don't know the molarity of the acid, and we do know the volume of the acid. So if you know these three things, but you don't know what's in red, you could solve for this, and then whatever you get in your calculator, that'll tell you the concentration. Now, what you're gonna do is this. You're going to add base until the color changes to pink. Once it changes to pink, you're gonna stop it. Okay, you're gonna flip the stopcock, and it's gonna stop the water from dripping. Then you're gonna plug in the concentration of the base times the volume of the base that you used up. How much base did you use up to neutralize this? And that's going to equal this, which is what you're trying to find, and the volume of the acid, which it tells you on the flask what that value is. So chemistry could be complicated, and your science teacher loves graphs, so we're going to look at a graph. On the y-axis, we're looking at pH, so the lower the pH, the more acidic. And as you move to the right, that corresponds to volume. So the lower the pH, the more acidic. You're adding more and more base. So base, you're adding base, the pH is going up, you're adding more drops of it. Oh, it's changing color, it's going from clear to pink. It's going to pink, but it's turning back to clear. It's still clear, and then it turns pink, and it stays pink. Then you stop it. You stop it from dripping. You stop the sodium hydroxide from dripping. And this is called your equivalence point. This is the point at which the number of molecules for acid is equal for the number of molecules of base. So equivalence point, the point at which there are equal amounts of acid and base. It's at a pH of 7, and the moles of acid is equal to the moles of base. So how do you calculate this using math? Well, you're going to start using this equation. MB times VB equals MA times VA. If you want, you could just put M initial time, not initial, MA times VA equals MB times VB. The reverse is the same. It's the same thing. You're going to get the same answer. So let's look at this question. So you're going to be writing this down on your notes. Question 1 says you have the liters of a 0.1 molar solution of sodium hydroxide, which is a base, and you need that much in order to neutralize the 0.125 liters of hydrochloric acid. So how do you solve this? The way you solve it is you're gonna first write your equation, of course. So my equation is going to be MB times VB is equal to MA times VA. So we do not know the concentration of acid, so we're solving for this. Do we know the concentration of base? Yes, the concentration of base is 0.1. So you're going to put 0.1. You're going to multiply that by, okay, so the 0.1 m. You're going to multiply that by the volume of the base, which is 0.54 liters. And that's going to equal the concentration of acid times the volume of the acid, which is 0.125. Then you're going to divide by 0.125 liters on both sides. Okay, the liters cancel. Once you solve for this, 0.1 times 0.54 divided by 0.125, the concentration is going to be 0.432 capital M, whatever the acid is, which is HCl. Okay, HCl. So if you can't read, it's HCl. Okay, so let's do another example. Example 2. So example 2, it says if it takes 0.1 liters of 0.051 molar solution of acid to neutralize the volume of the base, what is the concentration of the base? So in this example, we're looking at the concentration of base. So let's write our formula. Ma times Va is equal to Mb times Vb, okay? So what is the concentration of acid? The concentration of acid is 0.051. Multiply that by the volume, which is 0.14 liters, is equal to the concentration of base. That's what we're looking for. It says, what is the concentration of LiOH? So that's going to be your unknown. And then you multiply that by the volume of the base, which is 0.225. And you're going to solve for MB. And MB is going to equal 0.032 capital M, because that's the concentration of the base, which is lithium hydroxide. Okay, now you try example 3. Okay, you try example 3. Pause it now and then play again. So example 3. Example 3 says you're finding the concentration of hydroxide, so you should have written your formula. Okay, so what is the concentration of acid? The concentration of acid is 1.1 capital M. The volume is 2.54 liters. It's equal to the concentration of base, which is what we're looking for, times the volume of the base, which is 1.25. When you solve for MB, you're going to divide this on both sides, because you want to get this isolated by itself. And when you solve this, MB, which is a concentration, is going to be, let me look at my answer. My answer will be 2.24 capital MKOH. Okay, that's the base. So the concentration of our base is this. So again, titrations are used to determine the concentration of an acid or base using what we know. Plug it into the equation, solve, and that's your concentration of your unknown. Okay, so if you don't understand something, please rewind this and play it again. Thank you.